If you were at Prestonwood's Gift of Christmas this year, you probably saw these LED suits. I was going to walk through a little bit of how I did the software programming for them and talk a little bit about the hardware itself. So what you're looking at here are pieces of Kydex plastic with NeoPixel LEDs stuck, glued, taped, whatever we could use to hold them down, attached to that Kydex to go on lots of different parts of the drummers. So the coating's interesting on this. If we use just the chest as an example because it's easy to see, you think about how it was really envisioned was as a whole big grid, and so using this as a single kind of display, of pixels. So instead of trying to say, okay, well, I want this pixel and then this pixel and then this pixel to light up, and having to just like count and map, okay, that's the zeroth, because everything's zero based in computers, so 0, 1, 2, and then 3, 4, 5, 6, whatever, 18, 19, 20, 21, 22, 23, 0, 18, 23, and try to map all those out. It's easier to actually do the math. On the Arduino's been surprisingly fast. Like, it's doing a lot of math every second. Every time you see any sort of update on these things, it's actually doing a lot of calculations. What it does is, if you think about the first column, so you do columns and rows, and you set a 0, 0 point where you want to say, okay, I want this to be like the 0th row, and moving up, let's say. So if this is the 0th row, you can take the you take the number of rows, and then on certain columns you switch them, and I'll walk through the math just a little bit.
Okay, so my apologies a little bit in advance here. I haven't walked anybody through this code really yet, so I'm not sure exactly where this is going to go, but let me start. There's basically 3 files that run on this. I built a library called SuitGrid that handles most of the calculations of figuring out how to turn pixels on and off all over the suit. And then SuitGrid, it's called SuitGrid Test, is what actually is the programming for it. So I'll go through each one of these, and then there's a header file, .h file, for the SuitGrid library. And so this kind of gives you an overview of it. The SuitGrid.c++ is what does most of the calculations, and then the SuitGrid test is what uses that. And so in the SuitGrid.h, all of this stuff is really just to get the fast LED library installed. That's where all these includes are of all these other libraries. And then as I set up a library, and then I've got a bunch of constants defined. This is where a lot of the math will later reference. So this is how many columns and how many rows are in each component. There's also offset values to know, what are the LEDs ahead of this one, because it really, the suit is broken down into 3 sections. The legs are one section, the arms are the other section, and then the chest and drum another. So there you go. So if you look, the chest has 9 columns and 9 rows. There are some folded LEDs that I use as a offset, but then if you look here, there's 25 columns on the drum, so vertically columns, and then on the rows there are 8 rows. And the offset of where that starts is it starts at the LED after all of the chest row and columns, plus there's the ones that are kind of under the fold as it goes along, and so there's one of those for every column, except for like the last column, because there's no folded section after the last column. So the drum LEDs, if you think of it all as one big strip going from the chest down to the drums, the first drum LED is actually one more than all the chest rows and columns, like all of the LEDs on the chest. So that's where it starts. And so this is the offset. And I'll show how these calculations work. And then that's kind of repeated for the biceps, and the biceps are all the same. Like our left and right are the same, forearms are the same, thighs are the same, shins are the same. So there's all these little constants for where those go. And then I defined if I wanted to treat the whole thing as one big grid, whole suit is basically one big square, it would have 26 rows and 43 columns. That doesn't mean that there's 43 columns on every row, but I kind of create them and kind of have fake, kind of hidden LEDs that I only use in calculations. It's hard to explain, but maybe you'll kind of pick it up. I've got a few little diagrams I kind of put in source code to help me keep track of, okay, what's at the top. And so the bicep and the forearms, biceps and then the forearms and the chest and the drum are in the middle, and then you've got two thighs and shins. And then I was keeping track of which rows are on each piece. So on the bicep there are 6 rows, on the forearm there are 5 rows, and then the chest, like all the first 6 rows line up with the first 6 rows of the bicep, and then the next 3 would line up with the ones on the forearm, and then there's 2 on the drum, and then the top 2 on the drum would kind of align with those, the last 2 on the forearm, and the lower 6 on the drum would align with the first 6, the top 6 on the thigh. And then there's similar math for the columns, how those work, and so how those line up. I actually went in and did some more diagramming to figure out individually how I wanted to do some of the calculations. And so if you're looking, the row 0 is at the bottom of the suit. And so looking at there, you've got shins, and then there's kind of this blank area in the middle, and then there's other stuff. The shins go up and there's nothing, and then eventually it hits the drum. And you can see I skip a bunch of rows here because those were pretty easy to calculate. I didn't really have any math that I was trying to figure out for those. But I probably would eventually diagram out the whole thing. Some other constants I did were the modes of the different effects that I had. So you can see there's a bunch of different effects, and I just gave them all numbers. Stop is a -1, and everything else is there. It's just kind of arbitrary, don't really matter. And then a couple of test modes, and I put those all up in the 1,000 range again. So that's just kind of convention, this so that if I ever want to filter or something, I don't know, kind of arbitrary. Then there's I needed to keep track of whether the suit had been triggered from the primary or the secondary for figuring out what the timing was that was left. I may show that in a little bit. And then there's the actual suit grid utility class or kind of object that is how the suit is replicated or represented, I should say, in code. Here's all the methods and the implementations for all these are over in the CPP. This is just the header file. So you can see there's some things for getting the totals, and then there's ones for if you've got a row and a column, how do you find which pixel that should be on the biceps or the thighs, and for each one of those right and left, and they're a little different. But let's say you've got a row and a column. This is how many LEDs are in the top section, the bottom section, and that center section. Like I said, that's how it's broken up. Those will come into play just a little bit later. Then there's actually setting a suit pixel. So if you know which row and column you want to set on the suit, you can say this row, this column should be this color. And then if you want to know which color it is, what's neat about these NeoPixel strips is you can ask it what color it is. Well, with the fast LED library, I think it's just pulling it out of memory there. It's not actually asking the LED. It's just saying, well, this is the last color you set it to, so this is what color it should be. And so you can do a row and a column and get back a CRGB value for that. There's also some little utility classes I have for getting random colors with a certain brightness, and actually getting a random color from a list of colors with a certain brightness. Because sometimes we want a random color, but only from a select palette of colors, from a palette of purple or whatever, and I'll show some of those. There's also picking random spots. So if you just say, I want a random spot and I want it to have, be in this range of color and this brightness. And then here's some of the more useful or kind of the fancier ones. There's fading pixels too, which are actually using some of the fast LED libraries underneath. I'll show those. Fade on a row, fade on a row going down, center out, print suit colors, and I'll get into some of these. Printing out some of the stuff with serial, and printing out values. These are for more utility for just when I was debugging. And then those are all the private methods that are used internally. Then the actual, the public methods that can be used by SuitGrid test are all things that I made up. So if I want to loop through all the LEDs, if I want to light all the LEDs on the entire suit a certain color, I made up a little utility for that. I did some little tests, and then I've got some of the effects. I call them waterfall, chest blast, body blast with a percentage, fade on all pixels, test patterns, ripples, shows, a lot of stuff like that. So you can see there's, that's pretty much it. And then there's run current mode and set current mode for setting what mode the suit should be in. And running current mode is where most of the work happens, or where it's triggered from. So that's the header file. It's got a lot of the constants. Let's go over to the actual implementation for the suit grid. So you've got the pins on the Arduino board that it needs to be hitting. There's some direction constants that are set here. They probably could be set over in the header file. We need to keep track of which, maybe what our current index are. These are some different effects, kind of need to keep track of certain values as it goes. Here's 3 of the major variables that are used in a lot of places. These are CRGB arrays, one for the top section, one for the center section, and one for the bottom section of LEDs. So these are very large arrays. You can see the top LEDs are actually, like the size of these arrays are dynamically calculated based on the items that we've got, or like the pieces that they use. So for example, the top section is 2 biceps, it's a bicep and a forearm on the left side and a bicep and a forearm on the right side. So take the columns times the rows, take the forearm columns times the rows, add those together, and then multiply by 2 because you've got 2 of them, and that's how many LEDs you've got in the top section. And then similar math for the others. I won't walk through that. We've got a couple of colors, just like general colors we want to use, and then a couple of specific palettes they wanted to use. Here it is setting up those colors. These are all just hex values for the different colors. Won't go into those. Then when the suit grid is set up, so this is again in the library, does a random seed. So then when I need to do random numbers, it's always a little different. Here's setting up the fast LED library for each of the sections. You can see here's where I start using some of those methods of get top LED count. Setting the brightness. This is the overall brightness for the entire suit. If you look at the difference between 20% and 40%, it's actually pretty low in practice. And then when it sets it up, it says first turn everything off and make sure the mode, the suit is set to stop. Run current mode. A lot of magic happens here, where this is where, depending on what mode the suit is set to, it will do different effects. So a lot of times it's fading. So if it's doing a twinkle, first we just need to fade all of the pixels, turn everything on the suit just a little bit dimmer than it is, and then turn a random spot on to 25% brightness. That's what this is, and the implementations are lower, but it's basically how that works. And then, well, let's say you wanted it to be a twinkle, and I made like a medium version, a little brighter, so you can see it still fades all the pixels the same, but then it does a random spot at 50. And so the different effects are set up here. So twinkle fast blue, it fades all the pixels by this amount, 8 out of 255, and then it does a random spot using only the blue and white color palette, and it does it at a pretty high brightness, 250. But since it's fading them all pretty fast, that works pretty well. And there's different effects here. You can see most of them are just referencing some other effect, and I'll show how some of those work. But like when you do stop, just set them all to 0. And I've got a couple of test modes in here. Setting the current mode does a few little things where when you actually set a mode, sometimes it needs to initialize the mode to a certain thing. So in this case, it's lighting them all to a background. So if it's got a slow blue twinkle with a background color, it's actually lighting. The first thing it's doing is lighting all the LEDs, and then it'll go up here and let's see, that was twinkle slow blue with background, twinkle slow blue with that background. It starts fading all the pixels to this color, and then it picks a random spot in blue or white and does that. But there are things that only need to happen once, and so those happen when it sets the mode. So at the start of the mode, it does that. Looping through all the LEDs. There's some... I don't know if this one's actually used because there's still some to-dos in there. Light all LEDs. So this is lighting up all the LEDs to a certain color. So you can see it just loops through every single LED. So from 0 to entire, like to the bottom LED count. Light up the one at that index with the color that I created from the RGB values and light them all up. And I can actually do all of this very, very quickly. There's a kind of a pass-through method to call the fast LED library. Getting the total count is the top plus the center plus the bottom. Getting the top LED count is, like, again, kind of the bicep rows, forearm rows, and double that. It's possible that this could be referenced up at that other place where I do that same calculation, but again, this code hasn't really been seen by a lot of people, so I haven't done a whole lot of work to make it real pretty. When picking a random spot, it actually picks, you can see, based on the brightness, it first gets a random number and from 0 to 200, and if that's less than the brightness, then it goes and adds it. And so the idea is, if you make this brightness lower, this random value will less often be lower than that, and so it won't always hit. So as you lower the brightness, that actually lowers how often this code runs on a random basis. And so the top LEDs, again, it picks a random spot on there. So it says, okay, how many LEDs do I have? Pick one of those at random, and then set that to a random color. And so again, all of this calculation can be done just over and over and over again, just dozens of times per second. And so it moves very quickly. One thing to point out, this does require a Arduino Mega. We tried doing it with an Uno, but it doesn't have enough memory on it to do as many LEDs as we've got, close to 700. So the amount of memory that's required is pretty extensive. There might be a way to do it with an Uno, but we were kind of running into problems, and so it was easier just to buy a Mega because they're not that much more. Then here's another random spot for the brightness. And it's doing all the same logic again. That's probably repeating itself a little too much. I'm trying to see what's different here. I think this one just isn't using it. It's not from an array of colors, and so it's just doing the get random colors. So I could probably clean that up a little bit. Fading on a row. You have your target color. You build the color spectrum. So this is kind of a clever thing here is I make a whole bunch of colors, as many fade rows as I want. So I do a fade row, and the actual number of fade rows is 4 times the suit rows. And then, so I create a whole bunch of different colors here. I go through and I fade the target color, and then I fade it to black by just a little bit. And then I go through and turn those all on. So I go through for each suit row, or for each suit column, and then each suit row, I say whatever the current row is, go to the fade rows minus the R. This is how it changes through each loop. So each row is getting set to a slightly different color from this colors variable, colors array. And then it goes through, loops up through that. You can see this is moving the index up, which is that global variable that we've got inside this object, and so that keeps it. So the next time through, it'll say, okay, what's the current row that I'm on, and how do I kind of increment that. Fade on row down. This is basically the same code, but it's going the other way. It's actually I'm doing slightly fewer. It's doing fade rows by or suit rows by 3, but and then this is using set suit pixel, which I'll show a little bit later. Center out. This one's kind of clever because it uses, again, the index, and you can see here the index does get reset, and then it gets reset to 0 once it gets to the edge. And so it basically starts at the center and then it only turns on the pixels like in a certain range. So if the current index is greater than the center column minus the current index, but it's less than the center column plus the current index, what that'll do is find the two spots between two columns and then say, as long as it's in between, then set that to the color. And so it's a kind of clever to create a square box coming out of the center based on the index. Basically creates a box that's 1 away from the center, then it creates a box that's 2 away from the center, and then it creates a box that's 3 away from the center. And then if it hasn't been set, you see it's looping through every single column and row on the suit. And then if it gets set either way, it's true, and otherwise it's setting it to black. And it can just do this really fast. So if you look at the animations where it's showing the box coming out of the middle, which I may be able to show, it's pretty neat. And that's all it's doing there. Waterfall effect we didn't really use. Chest blast, this was one that we didn't end up using, or well, it was kind of the origin of the body blast. It's maybe a little simpler to show, but basically starts at one side and works its way up. I kind of explained that in the other video, so I'll leave that there. And so it kind of goes through and does different effects. Here's getting random colors. It just pulls a random color. This is not the get random color. Here's how to do suit ripples, wave effects going across them. See, I haven't cleaned up all the code real well. Suit wave, it's doing a wave up and down and lighting up one color to be a little bit brighter. Here it's actually picking, hey, what was it before? Set it to be whatever the color is, fade all the others as it goes along. Then there's like some funny stuff you got to do to turn the wave around so that after it goes all up to the top, you have to turn and get to start doing the other direction. So the wave direction, if it's up and then you've hit the edge of the suit, then you need to turn around. And so basically switch it from up to down. So that's kind of when you get to the edges. Some LED tests. These are things to just loop through. So here's where it just loops through, and this is the little test you see going up and down through the suit. So first it's like, maybe I need to turn the bottom ones on, then I need to turn the top ones on, then I need to turn the center ones on. Little sync test. This is a little flashy light on the corner, or on the arm, that goes from green to red to blue to black, green to red to blue to black. And so it's doing some just stuff by checking to see like, well, if everything's off, then turn on green, and then if green is actually something, but everything else is off, then turn to red, and then if red is actually something, then turn to blue. Otherwise, turn to black. And you can see, so there's lots of little effects like this, little test patterns and stuff you can do. And then here's where it does some of the getting the pixels. So if you know the row and the column that you want on a forearm, then to get the actual index, you take the forearm offset, and because this is the right forearm pixel, so whatever that forearm offset is, and then take the number of columns that you have, multiply that by the rows, and then you can, if you're on an even column, you add on forearm rows -1 minus the row that you're on, because you're going other way, you're going down. But if you're going up, it's pretty easy. You just add whatever row you're on. So as you're going up and down the forearms, you basically kind of add the ones that for every column that you're on already, and then add one, as many rows as you need to go up or down, whichever way. Left forearm pixel, right bicep pixel, these all kind of follow the same pattern of there's like this initial like easy calculation to kind of get you in the ballpark, and then there's a little bit of work you have to do to figure out, well, should you be subtracting from the total number of rows, rows -1, to get your index and then subtract the row, or should you add the row that you're on? And so they all follow that pattern. If there's if you're on column 0, then that zeroes out, and then you're just at your offset, and then you'll either subtract the number of rows or add the number of rows. Once you kind of figure one out, since they all follow the same pattern, it was pretty easy. Some random colors, pretty easy. Just using the random methods to look at indexes within. So like pick a random number from 0 to 10 and get that out of the colors array, and then it does some fading to black. I considered removing it, but didn't. Setting suit pixels. We do a little bit of filtering to make sure that you don't, in case somebody requests something that's outside the row. Setting the suit pixels. Getting suit pixels and setting suit pixels are probably the more complicated things here. So getting suit pixels, figuring out which color you should be getting. This actually took a long time to figure out, because this is where you have to think about that grid that was over here, this kind of stuff. Figuring out, well, if you're asking for this pixel, there's really nothing there. Now, should you give them this pixel because you're on the same row as that, or what? If you're in this, if you want the fourth row, third column, second index, fourth index, second index, well, okay, then you can do it from the shin. And so a lot of this stuff has to be figured out. If the row they're asking for is less than the total number of shin rows, then we know it's probably down there. And we know if the column is greater than the shin columns or less than the shin columns minus the drum columns, then you want to get the drum pixels. So what I did is actually I took the drum pixels and dropped them down. And so if you're in this section, I'm getting the last row of the drums and saying just use whatever the drum pixel is. But that was a choice I made. That's not necessarily a choice. That's not like the right way to do it. It's just a way to do it. And then there's all this kind of special logic for each scenario. So if you're on row 8, specifically row 8, that is the bottom row of thighs, of the thighs, then you need to copy. You can either copy them from the left side of the drum, or if you're between them, you can just pull the drum pixel, or you can get the bottom right of the thigh. So this is the, if you're on the thighs there, that may not actually be right. That may be a bug there. And then if you're in these rows, then you do this. And for these two columns, you do that. And the reason that you're like, well, what happens if you're not one of those two columns and you're 9 to 14? Well, there's it's greater than 9 and less than 14. There's only a couple that I care about. I don't know why that is. I guess you can't see them. Maybe that's it. I don't know. Because here, if the rows are between 5 and 16, then you want to get the center LEDs. Oh, because I have this way of getting it. If it's a suit pixel, there's an easier way to do it. If it comes back very simply, you can pull it there. So I'll show that. Yeah, get suit pixel. So here, this is kind of the first simple logic. First, it tries to do this, and then if this doesn't work, then this is the kind of fake pixels it's having to pull. Again, I haven't explained this. So getting suit pixels, you do kind of the easy stuff. If the row is less than 8 and it's on the left side, you pull the shin, the right shin. These are all right from the wearer's perspective, from the person who's wearing the suit. And then if you're greater than 34, then it's actually on their left shin. And again, and it follows like that logic. So if you're on row 20 and you're in the first 7 columns, then it's on the right bicep. And then if it's on, there's some kind of funny math I have to do in here. There's 9 on one side and 10 on the other, because you can't center it, because it's not a perfectly even, it doesn't fit perfectly. But if the columns are greater than all this stuff, or they're less than this, then it's in the left bicep. And then, or if I get all this way and I haven't found one, I return this, and that way I can say, I didn't find one from that method. And then, so this is kind of faking it of, well, if you pick one of those columns that isn't, or one of those pixels that's not really obvious what it should be, I have to kind of fake it, just so there's something. Printing them out and doing that. So where is the set suit pixel? So you can see here, it does get suit pixel, and as long as it's not null, so if it's not equal to null, then just set the pixel to that color. So setting the suit pixel was pretty easy once you know how to get a suit pixel. So if you can find the pixel and it's in one of the memory, if you can pull it from the bottom, the center, or the top LEDs, then all you have to do is find it and then set it to your new color. So it's pretty crazy how fast it can do all this work. And so that's where the majority of the work. If we go over to the suit grid test, which is actually the code, I started off as a test and I never renamed it. There's a couple of pins you care about. There's the timing button, the pin that comes in. There's some timings here for when different things should happen in the program. And they're setting up some buttons for basically when people hit those buttons, trigger the timing things. And then it loops through. Looks to see, was it pressed? Was it triggered by the primary or the secondary? Those constants coming back up. Setting mode based on time. That's you can see that's what it does here. Basically, hey, what time is it? 4:30. So we'll set the mode based on that time. And it says, hey, if this time is between these things, then we need to set the current mode. And you can see this kind of repeats down. So basically it is the time between when these timings were, and I named the timings saying, hey, if it's between fast twinkle and magenta suit, then set the current mode to twinkle fast blue. And then when that's done, a little utility method for checking to see where the time is. And then it says set the mode and then run that current mode, which goes back over and, like I said, just goes through and sets whatever the mode is. So it looks at whatever the current mode is and sets it. So there's run current mode. So set mode and then run mode. And so when it's running, it's doing all that. So this has been a real long, rambly look at the code that runs it. Hopefully, if you're trying to do something similar, this will show you that it's not crazy. It's definitely a couple, let's see, how many lines of code is it? 1,300 here, a couple hundred there, and then a couple hundred there. So a couple thousand, I guess, lines of code, but some of these are not necessary. And obviously, depending on how many effects you want to do, you might need more, you might need less. And this is also a very complicated suit design with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 unique or 10 pieces per suit. So if you only had 2 of these, it would be a lot simpler, and you could probably do it with a Uno. Really, the challenge we ran into was that we couldn't drive them all off of a single pin. So what we had to do is we had to break it up into those 3 pins to be able to drive it. I don't know exactly why. I don't know if it was a memory issue or if it was a signal issue. Running through more than about 300 LEDs, it just starts to get flaky on those last ones. So keep that in mind. But an Uno has the 3 pins, so you should be able to run 300, like maybe off of still off of a single pin. But even with an Uno, we could probably run 2 of these. So you could probably run 500 LEDs, 600 LEDs maybe on an Uno. But we were just getting above that when we got close to 700. So it was just easier to go to the Mega. Now back to some of the other stuff. Here's what it looked like backstage when we were about to do that sync. All the guys have their back to the sync box, and there's actually a little wire running from it to each battery pack and Arduino in there. There are buttons so that we can manually switch it and run. There's a primary signal and a secondary signal in case the primary one, in case we had something hooked up wrong, but pretty cool.
So yeah, this I call this the body blast because it comes out of the middle. And so what it's doing is once I figured out all that math to do okay, turn on for the entire suit. I want position 15, 15 or whatever. So I basically just start at the middle and I keep track of the math, working my way out of okay, first light up column 15, row 15, then light up everything that's on row 14 and below that, and go everything between column whatever 14 and column 16, and kind of start spreading each of those out. Spread out the columns and move the row down, and then that blast. Some of these twinkle effects, these are pretty easy. These are just picking random numbers. The Arduino has a nice random number generator, and so I'm just picking a random number in the entire set, and so every suit looks a little different, keeps it from looking too repetitive, can't be controlled. And then there's these row effects where it actually goes across from row to row. Again, once I figured out the math of, okay, I can light up a single row or a single column, it's just programming that in there with, okay, set this row to be brighter, every other row to be dimmer, push all those pixels out, and light up the suit. And it's doing that several times per second, lighting up all 690 pixels. You can see here's kind of our magic pixel. It's right in the middle, and then things kind of blast out from that. Some of these effects, it's actually it starts at the bottom, and it says look a little closer to the middle, average out some of those pixels, and copy those down, dim them a little bit so that it doesn't just keep the brightness all the way. So this pixel will be looking to see, what are these 3 pixels doing, averaging those colors, pulling it out here, dimming it just a hair, and then, that's your color. And then it does that, and it goes through, and it's actually doing that for the entire suit every single time. So anytime you see it flickering and changing, it's doing that. So here it's picking random numbers from all over the suit and just throwing those on there. It creates a nice little twinkle effect. And then light up the whole suit blue and slowly fade it out. So yeah, it was a really fun project to work on for a couple of months. We started back in the summertime before GOC. Big shout out to Lyle and Al and all the guys who worked on the hardware itself. Those guys put way more hours into it than I did doing the software. It wasn't super easy. It was quite a few hours, a couple dozen hours probably over the course of months, just trying to figure out the math for it. And then every piece was a little different, and parameterizing it, trying to make it so that we could change things. We actually had to little behind the scenes thing. The chest panel that I had for doing a lot of my tests was a little different than the rest of them. It had one extra column, and we needed to change it for the actual suits because it was causing everything to be off just a little bit. And so I went in and changed the one parameter to what it should be for all the suits, and things actually worked. I was never able to find a problem with any of the animations after changing that parameter. So it means I feel like pretty good about it. There's probably still some bugs in it, and I'm sure not everything went exactly according to plan, but pretty cool. If you've got questions, feel free to leave them down there, and I'll try to respond to the questions about how the suit works, how the programming works. Maybe there's some little tricks in the math that if you're wondering, what's the math used for any of the effects you saw, leave a comment. And so have a good one. There we go. Sinking. Little blinky light. Got it. Elves.